So first we're going to review how to put an equation that has been expanded, like the one you see here, for a circle back into that standard circle form that we know. And we're actually going to use a process we already know, our completion of the square process. So to start off, I'm going to organize our terms, our x terms, our y terms, and our constant term. So you can see here I've placed 4x squared minus 16x and 4y squared minus 24x together and left that constant, which I'm going to move to the other side to begin my completion of the square process. So if I subtract 51 from both sides, I am left with this equation, which looks a little more like what we want with our equation for the circle, but isn't there yet. So the one thing I'm going to note is that if you notice in my first term here, my x terms, there is a greatest common factor of 4, which I'm going to take out or factor out. And then in my second, my y terms here, there's also a greatest common factor of 4. So I'm going to go ahead and factor those out. So you'll see I took the 4 out to get a more simplified version. And now I'm going to divide both sides or multiply by 1/4. So if I divide by 4 or I multiply by 1/4, that's the same thing. So when I have 1/4 on this side, I'm going to multiply by both of my terms. So I'm going to multiply by this factor or term with my x's and this factor or term with my y's. So you can see I get 4 over 4 plus 4 over 4 with my x and y terms, which are going to end up canceling out, and negative 51 over 4. So in my most simplified form that is ready to undergo my completion of the square process, I end up with x squared minus 4x as a term in which I want to complete the square, and also y squared minus 6y, which is another completion of the square process, with my constant value of negative 51 over 4 on one side. So now, if you guys remember, we're going to use our completing of the square process. And we're actually going to have to use it twice, because we're going to have to complete the square for our x values, and we're also going to have to complete the square for our y values. Because if you remember, the equation, the standard form of equation for a circle has 2 squares. So when we start, where we want to go with x squared minus 4x is we want to get a square in which we have our b term divided by 2. So where we want to eventually go is to have x minus 2 squared. So if I expand out x minus 2 squared, you'll find I get x squared minus 4x plus 4. So we have x squared minus 4x, but if we want to get to this perfect square, we have to add 4. And with our y terms, we want to get to a perfect square in which we want to complete the square in which we get y minus, and we want to take b over 2, so y minus 3. So y minus 3 squared, and if we expand that out, we get y squared minus 6y, which are the 2 terms we have, and then we add an additional 9. So what I'm going to need to do to both sides of this equation in order to complete the squares is add this 4 and add this 9, or add 13 to both sides, because remember, when I do an action to one side of an equation, I have to do the same action to the other side of the equation. Otherwise, I'm not remaining consistent and I'm changing the actual equation into something different. So if I go ahead and do that, I'm going to have x squared minus 4x plus 4 plus y squared minus 6y plus 9. And again, we have to add to both sides. So to my negative 51 over 4, I'm adding 4 plus 9, or that 13. So if I look at these, I can factor this x value now to our completed square, and I can factor this y value to our completed square. So now I get x minus 2 squared plus y minus 3 squared, which is exactly what I want for my standard form of my circle. And now to simplify, I get negative 51 over 4, and I convert 4 over 4 to 16 over 4, plus our 9 is now 36 over 4, which it ends up being negative 51 plus 52 all over 4. If I simplify this further, I get x squared plus y minus 3 squared equals 1/4. So now I'm in the right format, so let's interpret what this means. So if you remember the equation of the standard form of a circle, I have x minus h squared plus y minus k squared. And those h and k values are going to result in translations of shifting this left and right for h and shifting this up and down for k. The r squared value is going to get me my radius, or my r value. So my center again is at the value of h, k, and my radius is at r. So if you look back at our formula, my h value is 2 because I have a negative and a negative here. So my h value is just 2. My k value is going to be 3. And r squared is equal to 1 over 4. So we don't know the radius yet because r squared equals 1 over 4. So I'm going to find my center is at 2, 3, which is h and k. And then for r squared, to get that value, I need to take the square root of 1/4 to find my actual radius value. So in this case, the square root of 1 over 4 is 1/2. So the radius of this circle is going to be 1/2. So now I've completed that conversion process. So let's just graph it and check that we did this correctly. So now I'm in Desmos, and you can see I have graphed my original circle, the equation that they gave us in this problem. I also have graphed our converted form, so the form that we just found. And if you see, if I click this to be visible, that they're the exact same circle, which is what we want because we want items to be equivalent. So you'll also notice if I graph the point 2, 3, that's going to be the center of my circle, which we found from our format of the circle. And you will notice that the radius is also going to be 1/2. So if you look at the diameter, it's 1 unit. And if I go and look at any point and look at the radius, it's 1/2. So we know we've done our conversion and interpretation of the standard form of the circle form correctly. So now you guys give it a try in your homework assignment.